Hello everyone, and today I want to tell you shortly about a paper that called LLMs are zero-shot reasoners, and let's start. Um, we all know that LLMs are pretty decent few-shot learners, especially when we use in chain of thought prompting, which provides state-of-the-art performances in different arithmetic tasks. But it turns out that large language models are also decent zero-shot reasoners. So the proposed approach, zero-shot chain of thought, that called zero-shot chain of thought, uses the same prompt template across different tasks, and this approach outperforms plain zero-shot performances on diverse benchmark reasoning tasks that include arithmetic, symbolic, and other logical reasoning tasks without any handcrafted few-shot examples. And such versatility of this single prompt across very diverse reasoning tasks hints at untapped and, I think, understudied fundamental zero-shot capabilities of large language models. So all you need to do is just let's think step-by-step phrase before each answer, but let's look at everything step by step. While few-shot chain of thought prompting solves the issue of struggling LLMs at slow and multi-step reasoning tasks, the main drawback of this approach is that it needs carefully crafted and task-specific step-by-step examples, which is pretty time-consuming. But by only adding a single prompt before answering the question, we can prove that large language models are decent zero-shot reasoners. Despite such simplicity of this approach, zero-shot chain of thought successfully generates correct reasoning in a zero-shot manner while being versatile and task-agnostic. As we can see at this slide, the plain few-shot and zero-shot prompts didn't solve our task successfully. However, few-shot chain of thought was successful there, but as you can see, we need to give the task-specific examples of reasoning, and it's pretty hard. And also we can see that the zero-shot chain of thought also handled these tasks easily, but we didn't use any human-crafted examples. While zero-shot chain of thought still underperforms few-shot chain of thought in different benchmarks, but the proposed approach gives enormous score gains compared to the other zero-shot baselines, and also with such approach, we have a significantly better scaling curve comparable to the other few-shot chain of thought baselines. So the proposed zero-shot chain of thought approach looks like. Actually, this approach consists of two prompts, and firstly, we use a reasoning prompt to extract a reasoning path from our language model, and then we need to use the answering prompt to extract the answer in the correct format from the reasoning text. So you can see this schema at the slide. And to be more specific, for reasoning extraction, we need to modify our input question into a prompt using template, which you can see at the left side of the slide. And the interesting thing here is that we can use a trigger sentence that extracts our reasoning from the input question. And by default, as I said before, we use let think step by step as a trigger sentence. But other variants also described in this paper, and we can use whatever we need. It all depends on our task and dataset. Then the prompted text is fed to language models, and we can generate reasoning. Then for answer extraction, it's the right side of the slide. We simply concatenate our first prompt, our generated reasoning, and trigger sentence, but for now it's trigger sentence for answer extraction. And by default, we use the trigger sentence, the answer is, but we can use other variants as well. Of course, we want to see the benchmark results, but let's first discuss details of the experiment. And authors compare it few-shot chain of thought to standard zero-shot prompting, and for zero-shot experiments, similar answer prompts as zero-shot chain of thought are used as default. And also for better evaluation of reasoning tasks, the authors also compared the proposed approach to few-shot and few-shot chain of thought-based lines using the same in-context examples. So as for the data, this approach was evaluated on 12 datasets from 4 categories. It's arithmetic, common sense, symbolic, and other logical reasoning tasks. And 17 models were tested. Main experiments conducted with Instruct GPT, different versions, original GPT-3, Palm, GPT-2, GPT-Neo, and other models as well. So as for results, the zero-shot chain of thought substantially outperforms 4 out of 6 arithmetic reasoning tasks, all symbolic reasoning tasks, and other reasoning tasks. Only in common sense reasoning there is no significant improvement, but it's expected because even few-shot chain of thought approaches doesn't provide decent performance gains here. Also, we can check more detailed comparison of the approaches on 2 arithmetic reasoning data sets, and as we can see that zero-shot chain of thought achieves score gains, enormous scan gains on multi-ARIS and GSM-8K datasets, and for the remaining arithmetic reasoning tasks, this method gives on-par performances, which is expected since they don't require multi-step reasoning. The large gap between the first block and the chain of thought prompting second block suggests that these tasks are difficult without using multi-step reasoning. And my major improvements are confirmed on both Instruct GPT and Palm models. And also, while zero-shot chain of thought naturally underperforms few-shot chain of thought approaches, but it substantially outperforms standard few-shot prompting, even with 8 examples per task. And as this figure, we can see LLM's performance comparison on multi-ARIS and GSM-8K datasets. And as we can see, without chain of thought reasoning, the performance doesn't increase, so increases very slowly with the model scale. And in contrast, the performance drastically increases with chain of thought reasoning as our model gets bigger. So that's why using the smaller model for chain of thought, even for zero-shot, is not effective. And yep, I guess that's all. So thank you. Any questions?